Okay, so we're going to be going over problem 6 from the handout, which is basically problem 2, which is with the ant and the anteater, except the ant has a movement speed of 2, and then the anteater has a movement speed of 2. So we'll do the first part first. The ant has a movement speed of 2. So here I have the octahedron drawn out. It's just 1, 2, 3, 4, 5, 6, or as the vertices are like numbered. And then notice that if you have 1, you can go to 2, 3, 4, 5 as your next move. 2, you can go to 1, 3, 4, 6. 3, you can go to 1, 2, 5, 6, and so on. So what we're going to do is we're just going to take the states every 1 second, because at half seconds, the anteater moves at only 1 side length per second. So it's still going to be moving like in the middle of a vertex. And that makes a lot. It could be in the middle of an edge. And that makes too many confusing scenarios. So the first thing that we're going to do is just draw our diagram. 2 away, 1 away, dead. And we start at 2 away. So the anteater, without loss of generality, let's say it starts at 1. And the ant will start at 6. So the anteater, without loss of generality, goes to 2, since it goes to a random one between 2, 3, 4, and 5, right? And the ant, well, the ant's dead if it goes straight to 2, obviously, right? So the chance that the ant goes to 2 is 1/8. So we're going to put that here. The chance that the ant goes to 1/8 is, the chance that it goes to 2 is 1/8, because there are only 2 ways for it to get to 1/8. To get to 2, I mean. It goes to 4 and then 2, or it goes to 3 and then 2. And then the other way that it can die is if it goes to 2 first and then it goes to 1. And I wrote 1s there because it takes 1 second for the ant to die. But in this scenario, that has a 1/16th chance. If it goes to 2 and then to 1, that the ant actually dies in 2/3 seconds. So those are the scenarios where it dies. Now, what about the other scenarios? What if it goes to 2 and then to 3 or 4? Then we have it ending up being 1 away from the anteater, because the anteater goes to 2. And similarly, if it goes to 5 and then 4, or 5 and then 3, then it ends up 1 away. And it also ends up 1 away if it goes from 6 to 4 to 1, or 6 to 5 to 1, or 6 to 3 to 1. In total, that makes 7 different ways. So that's 7/16. And then another case that can happen is if it stays 2 away. So if it goes to 5, and the chance of that is 1/8. So notice that we're missing some cases. If you add up all these probabilities, you have 1/8 plus 1/8 plus 1/16 plus 7/16. It's only 3/4. So the rest of the probability happens when you go back to 6. You go to 5, 6, 5, 6, 6, 2, 6, 6, 4, 6, or 6, 3, 6. So then you end up 1 away, since 6 is 1 away from 2. So first equation is just going to have to do with our 2 away. And let's say E2 is the expected lifespan when it's 2 away. So E2 is equal to 1/8 times E2 plus 1 because it takes 1 second to get back to that position, plus 11/16 E1 plus 1 and then plus 1/8 times 1 plus 1/16 times 2/3, which is going to be 1/24. So now we tackle the case where it's 1 away. So the ant, let's say the ant is on 1 and the anteater is on 2. And obviously the anteater is going to have to go to 1 since that's the closest path. If the ant returns to 1, which is a 1/4 chance, then it'll be dead. So 1/4, and then it takes 1 second to die if it returns to 1 because that's how long it takes to return to 1. If it goes to 2 right away, actually no, it's not 1/4 actually. The reason why it's not 1/4 is because I counted the probability that the ant goes to 1 and to 2 and then back to 1. So that doesn't count. So there's only a 3/16 chance of dying in 1 second. And then there's a 1/4 chance that it heads to 2. And then it'll die in 1/3 second. Because the total speed of the anteater is 3 side length per second, and it's traveling a total of 1 side length. So if the ant's on 1, and it doesn't go to 2, then it can go to 4 to 2, which is 1 away, 3 to 2, which is 1 away, 3 to 5, which is 1 away, 4 to 5, which is 1 away. So it should be a 1/4 chance that it goes to 1 away by those 4 methods. And then if it hits a 6, which is a 3/16 chance, then it's 2 away. And it's 3/16 again because it can't go through 2, or it'll die. So if you add up the probabilities, then we have a total of 14 out of 16, which is still missing 2 cases. And those cases are if it goes to 5 and then 4 and 5 and 3, which also puts it at 1 away. So we're going to add 1/8 to this here. Not 1/5. So now we have our second equation. That is going to end up being E1 is equal to 3/16 E2 plus 1 plus 1/4 plus 1/8, which is just 3/8. 3/8 E1 plus 1. Can't draw. It's like really laggy. So 3/8 E1 plus 1. And then plus, it's going to be plus 3/16 times 1 plus 1/4 times 1/3. So now all that's left is our simple system of equations, and we should be able to solve this. Okay, so now that we have our 2 equations here, we can just solve. First of all, we don't like fractions. So I'm going to multiply this first fraction by 48. And we're also going to just make E1 and E2 xy to make it easier. E1 is going to be x, E2 is going to be y, and y is our answer because they start 2 away. So 48y is equal to, and then just multiply by 48. So it's going to be 6y plus 6 plus 33x plus 33 and then 1/8 becomes 6, 1/24 becomes 2, so we add 8. And then the second equation, we multiply by also 48. So we have 48x is equal to 3/16 becomes 9. So it's 9y plus 9 plus 3/8 becomes 18. So 18x plus 18. And then 3/16 becomes 9, 1/12 becomes 4, so it's 13. So now we'll simplify the equations. So 42y plus 33x is equal to 14 plus 33, 57. No, 47. Yeah, these numbers are probably going to get messy. 14 plus 33, yeah, 47. And then 48x with minus 18x is 30x. Oh, this is actually, no, this is going to be minus 33x here. Let me erase that. $30x minus 9y is equal to 40. Then let's just multiply these equations out. So 42, we want to cancel out the x's. So the common factor here is 3. Multiply this equation by 10, multiply this one by 11. So we end up with, I'm just going to write 420. I'm going to write it in kind of matrix form. So for minus 330, I'm going to do x, y, and then the constant. This is not really matrix form, but it's just drawing is hard on the computer. And then the second equation, multiplying by 11, we have 330. Oh, not minus 33, minus 330. And this multiplied by 11. And then 440. And if we add, then 321 y is going to be equal to 910. And then y is just 910 over 321. And that's our answer. Not the cleanest problem, but should probably draw that better. And that's our answer for part A. All right, now we're going to head over to part 2, which is when the anteater has a movement speed of 2 cycles per second. And notice since the anteater is chasing down the ant, it moves towards the closest path, right? So we can notice that if we're trying to solve this problem, that our expected value is probably going to be smaller than this value, 910 over 321 that we found for the part A. So let's say our ant is on 6. Without loss of generality, let's say it moves to 5. Since 5, 4, 3, 2 are all pretty much the same thing in the eyes of the anteater, because they're all like symmetrical with regard to 1. So let's say the ant goes from 6 to 5. And let's say the anteater starts with 1, goes to 5. Then that's dead already. And it's dead at, well, no, it's actually not. No, it is dead already, because once the ant goes to 5, the anteater goes to 5, then the ant will be halfway from 6 to 5. and the anteater will choose the fastest path, which is this edge from 6 to 5. So it'll head straight for that, and they'll meet, and they'll die at 2/3. So the chance of that happening is 1/4. Oops, I used the red pen, but that's fine. So 1/4 chance of dying in 2/3 seconds. Now, if the ant goes to 4 or 3, then the fastest path, well, this time, it actually is going to be either 6 and 5 are the same distance regarding the ant, because the ant is going to be halfway between 6 and 5. The anteater doesn't know which way the ant is going. Like, even though the anteater technically knows which way it's going, it's not really, because we can't assume that in the problem. So the anteater will have to pick between going to 6 or going to 5. And there's a half chance that it goes to 5. So there's half chance that it goes to 4/3, which means that it's another quarter that it dies in 1. Because if the anteater ends up going to 5, then it will kill the ant. If not, then it'll end up 1 away. And what we notice with all the other cases is that if it goes to 2, then it'll end up going to 4 or 3, which is or 1, actually. It could go to 1, 4, or 3. But it doesn't actually matter, because since the ant is going to... Wait, actually, no. It's gonna it's gonna have to go to 6, because if it goes to 2 and then 6, that's the closest one to over here. But it actually doesn't matter where it goes, since as long as it goes to 1, 3, 4, or 6, it's always going to be 1 away. So if it goes to 2 first, then it's going to be 1 away. And then the other possibility that we were talking about, it's also going to be 1 away, which means that there's a half chance that it's 1 away. It will never be 2 away after 1 turn. And after 2 turns, then what you'll notice is that when it's 1 away, then it's a guaranteed kill for that anteater. And that's because it'll start heading toward the ant, but it'll be faster than the ant, so it'll catch up. And there's a 1/4 chance that it dies in 1/3 second, and that's if the ant goes straight towards the anteater. And then there's a 3/4 chance that if the ant does not go to the anteater, that the anteater will just kill it in 1 second. So now it's time to make our equations. If I could draw that, probably. Wow, that's really laggy. Okay, so our first equation is going to be the one for 2, E2. So E2 is going to be equal to, we just sum the 1/2 E1 plus 1/4 times 2/3 plus 1/4 times 1. Oh, 1/2 E1 plus 1. And then plus 1/4 times 2/3, which is 1/6, and then plus 1/4. And then E of 1. E1 is easy to solve because there are no other variables in this equation. It's literally just going to be a bunch of numbers on the right-hand side. And that bunch of numbers is just 1/4 times 1/3, which is 1/12, plus 3/4. Yeah, my thing is not working well. So 1/12 plus 3/4 is simply 5/6. So now that we know E1 is 5, 6, we will just do some plugging it in to our other equation. So that is going to be E of 2 is going to be equal to 5/12 plus 1/2 plus 1/6 plus 1/4. And 1/2 plus 1/6 plus 1/4 is just 6/12 plus 2/12 plus 3/12, which is 11/12. And then 5/12 plus 11/12 is going to be 16/12, which is our answer. And if you simplify that, that is 4/3. And that's E2, which is our answer since they start 2 away from each other. Always make sure you're using the correct variable in these equations as your answer. Otherwise, you're going to get the wrong answer, even if you went through all this hard work and did everything correctly.